Let's switch gears and look at the Node.js approach to tables. First, it uses SQL Server just like our ASP.NET approach. Also, like the ASP.NET approach, the Node.js backend exposes an OData endpoint to query and manipulate the data. However, unlike ASP.NET, we can configure the database table completely through the Azure Portal. And they call this easy tables because it's easy, and there's no code required to set it up or get it running. And finally, even though code is not required, you can add code in JavaScript to do some basic server-side logic for each of the HTTP requests and database operations. And this is similar to the table controller in ASP.NET, and it's done through a set of JavaScript functions that you can add to the Node.js server files. We cover this topic in a later class when we talk about authentication support. Easy tables are quite easy to set up. There's an item in the mobile section of your app properties which walks you through the setup process. When you select this option the first time, the portal will warn you that you need to configure easy tables. You can click the header bar to start this process. If you are using an ASP.NET backend, the portal will display unsupported service when you select this item. You have to do your setup in code for that approach. This setup process has two steps which the portal will walk you through. The first is to set up a SQL database and a connection string. We covered this earlier and the steps are identical here. The second step is unique to the Node.js backend. You must initialize the server to support easy tables. Effectively, this sets up folders on the server like /tables and /API, as well as some of the basic Node.js configuration. Once you've set up the database and initialized easy tables, you can start adding tables to expose through your service. This can be done in two ways. It can be done through the Azure Portal or the web server configuration files. The portal is by far the easiest way to create new easy tables. This adds the table definition and creates a SQL Server table using your associated SQL database. You must apply a unique table name, which is created on your SQL Server instance. This also becomes the endpoint name that you're going to use to interact with this table. Then, you must define the network permissions to access the table. You can define the permission required for each operation type. The default is anonymous, which means there's no security required. We will cover adding security to our tables in a future authentication class. Just like the ASP.NET version, when Easy Tables creates the SQL Server table, it has 5 mandatory columns added to the schema. The ID field is a string. It could be anything, but it has to be unique as the ID, and it's going to be the primary key. If you don't specify it, Azure Mobile Apps will assign the string representation of a GUID to this field. The created@at field is a date-time offset field in SQL data format terms that represents the date and the time that the record was created. The updated@at field is also a date-time offset field that represents the date and time of the last update. The version field is a base 64 encoded string that represents a unique version. The deleted field is a Boolean. It represents that the record has been deleted, and that is used to support cross-device or soft deletion cases. As mentioned earlier, you can add these columns to an existing table as well, or use this definition to create your own table directly instead of through the portal. Need to fill in the fields with a unique value and add a trigger on the updated@at field to set it when it's changed. If you take a look at this blog post, it has all the details on that approach. Once you've defined your easy table, you likely need to add some unique columns to it to store your app-specific data. This is done by selecting your table in the Easy Tables view and then selecting the Manage Schema toolbar option at the top. This opens an editing blade for the table, and that lets you add and remove columns from the table definition. Any operations that are done here will change the schema of the SQL Server database table. The main thing you likely want to do is to add new columns to your schema. When you click the Add Column button, it will prompt you for the new column information. You must add a unique name for the column. This is the column name and the field name in your DTO, so make sure you use a compatible name here, like spaces are a bad idea, for example. You must select the column type, and there's a limited selection here, string, number, date, and Boolean, which map to the JSON data types. The column types are turned into equivalent SQL Server data types. So string is going to go to the nvarchar max, number will go to a float 53, date is going to a date time offset, and Boolean goes to a bit. Make sure you name the column and choose the type carefully. The portal does not allow you to change the column definition once you click that OK button. And it should technically be possible to connect to the underlying SQL database and alter the column, but you can't alter the name or the type of the column through the Azure Portal. Once a column has been added, it shows up in the table list on the portal. There's a context menu at the end of the definition which lets you do additional operations on the column. You can delete the column and all its data. You could add an index to the column, and adding an index speeds up searching on this column by creating a database index. You don't need an index to search against the column, but it could help. And you can delete an existing index. Once we've got a table set up, we can interact with it using HTTP-based operations. Our clients are going to connect to a known endpoint on the service. Tables are always exposed from /tables/ whatever the table name is. This is a requirement of the mobile client infrastructure. If you change the routing, then the client is going to need to write the access code instead of just relying on the SDK. It also breaks all of the built-in features like offline synchronization. So don't change the routing. When our client hits the endpoint with an HTTP GET request, the service will perform an async query against the configured database and the specified table. The table has to be configured with either table controller or easy tables on the server side, or you're going to get a 404 returned. The database will respond with a set of rows or a count of the affected rows. The server will then take that response and then package it up as a JSON packet and send it back to the client. To test your tables, you can use any REST client test app. Just use the site URL and then add /tables/ whatever your table name is. And that's going to hit the proper endpoint. Here on the screen you can see a list of some common favorites, but there's plenty of other testing options out there as well. For a GET request, you can simply make the request to the endpoint. But for a post, a patch, or a delete, you're going to need to send an HTTP body along with the request in order to specify which resource that you want to act on. And you're going to set the content type to be application/JSON.